Welcome to section 8.5. Thanks again for joining for these optional notes. What we're going to be covering here is just these 5 slides. I will warn you that this video probably is going to be a little bit on the longer side, as I'm sure you've already realized. And that's just because binomial expansion takes a little bit of time. So I'll move through certain things a little bit quicker, but I want you to have this so that you can go back to it. I know it's a little bit longer though, but it's optional. You opted to be here. So find the following binomial coefficients. So this is doing like that n choose r. So here, this is doing n choose r, where your formula for n choose r is n factorial over n minus r factorial times r factorial. And what this allows you to do is jump to the coefficient from Pascal's triangle. So in the other video, you would have heard that I said that you don't have to memorize all of Pascal's triangle. It continues on infinitely. But if you're looking for a specific binomial coefficient, you can jump to that coefficient using n choose r. And we'll show you how in the calculator, not in this video, but in class, I'll show you in the calculator how to do this as well to just jump forward. So 3 choose 2 means that we're doing 3, 2, same notation for that same thing, which means that we're going to have 3 factorial over the difference of these, 1 factorial, times r factorial, which would be 2 factorial. Factorial means that I'm multiplying, so 3 times 2 times 1 over 1 times 2 times 1. And 2's and 1's cancel, and I just get 3. So I would know then that the binomial coefficient here is 3. So 5 choose 2, again, what this means is 5, 2. There's no over in that. I don't know why I wrote it as a fraction. So this is going to be 5 factorial over 3 factorial, 2 factorial. The difference between the two numbers, and then the r value. So another way that you can sort of write this is just 5 times 4 times 3 factorial over 3 factorial and then 2 times 1. So here's 2 factorial, here's 3 factorial, and this is 5 times 4 times 3 times 2 times 1 is 3 factorial. So I can easily cancel that off now and reduce that to 2 to get a total of 10. So this is telling me in Pascal's triangle, if I had something that was raised to the 5th power, and I was looking for an r value of 2, which would mean that we're actually talking about the 3rd term, we'd have a coefficient of 10. And if you're curious if I'm right, you can pause this and just go back a slide and you can double check me. Here I'll have 7 factorial over the difference of these, 3 factorial times r, this is r factorial. So that's going to be 7 times 6 times 5 times 4 factorial over 3 times 2 times 1 times 4 factorial. My 4 factorials cancel. 3 times 2 gives me 6. So this will give me 35. Notice I'm doing this by hand. I'm not multiplying it all out. 10 choose 4 will, 10 choose 4, so I have 10 factorial over the difference of these, 6 factorial, times r factorial, 4 factorial. R being 4 means I'm talking about the 5th term. Okay, so we're going to have 10 times 9 times 8, that's a terrible 8, times 7 times 6 factorial over 4 times 3 times 2 times 1 times 6 factorial. Notice I'm writing out all of the smaller one, and I'm stopping it at 6 factorial because those can cancel. The 4 and the 2 would give me 8, and 9 over 3 will give me 3. 10 times 3 is 30, times 7 is 210. So now I've jumped to a number or a location in Pascal's triangle without actually writing it all out. 9 choose 9 is what that means. I'm doing 9 factorial over the difference, 0 factorial, times r factorial. Something about 0 factorial to remember. By definition, this is 1. So we have 9 factorial over 9 factorial, which is just 1. Meaning our coefficient, if we were doing 9 choose 9, is just 1. You're essentially saying, in how many ways can I pick 9 things? I'm sorry, how many ways can I choose 9 things from 9 things? Well, only one way. All right, we're skipping that next slide, and then we're going to go through these examples. These are the ones that are going to be a little bit longer, but you are going to see it's a tedious process, but an easy process. So I'm going to start with one color. I will switch colors for each thing that we do. Use the binomial theorem to write out the expansion. Again, we're going to take up a lot of space here. So first thing, I look at the degree. I'm raising this to the 5th power. What that means is there are going to be 6 terms, and that term always starts with a coefficient of 1. The next coefficient is always the degree, so 5. The next one that I'm going to have is going to be 10. Sorry about that. So we're going to have 1, 5, 10, and then 10, 5, 1. Remember that this is always symmetric. This is that row from Pascal's triangle. And let's say you didn't know this 10. This is also the same as just 5, choose. This is the 3rd term, which means the R value is 2. So if you did 5 choose 2, which I think we did here, 5 choose 2, you get 10. 10. Amazing. Okay, so that's going to be our binomial coefficients. Now, what we also have to do is talk about our x's. So right here, x is in place of x. So this is going to go x to the 5th, x to the 4th, and in this case, you don't really need the parentheses. I put them a lot of the times because in certain cases, it will make a difference, and you'll see those cases. X to the 1st, and you don't need an x here, it's x to the 0. Now I'll switch to pink. So 1 is being used in place of our y term, our 2nd term. So this is 1 to the 0, then 1 to the 1st, 1 to the 2nd, 1 to the 3rd, 1 to the 4th, and 1 to the 5th. So now I have all these separate terms. To write my final answer then, 1 times x to the 5th is just x to the 5th, plus 5 times x to the 4th times 1 to the 1st is 5x to the 4th. 10 times x cubed times 1 squared gives me 10x cubed, plus 10 times x squared times 1 cubed is 10x squared, plus 5x plus 1. So we were able to essentially multiply this out to the 5th power without actually multiplying any of it. All right, y plus 2 to the 4th power. So right away I see it's to the 4th power. I'm going to do my binomial coefficients first. So my binomial coefficients to the 4th power is going to be 1, 4. It always starts off like this. I'm going to have 5 terms because it's always one more than that. I know that this middle one is 6, 4, 1. All right, then I'm going to go to the quote-unquote x. So this is weird. Y is being used in place of that x, and I'm doing air quotes right now. You can't see them, but it's being used in place of that x, that 1st term. So this will be x to the 4th, x to the 3rd. Oh, sorry, erase that. I'm just lying to you right now. I got lost in my own thoughts. Nope, not forward. This will be y to the 4th, y to the 3rd, y squared, y to the 1st. And then this is our y to the 0. Then I go to my quote-unquote y, which is 2 in this case. So here I'd have 2 to the 0 power, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th. Remember that what should happen with these is that your exponents, in this case in the blue, my exponents should decrease, and in pink they should increase, starting from 0. Also remember the way that I do this, the pink one will always be our quote-unquote y. That is the R value. So here, R was 1, R was 2, R was 3, R was 4, R was 5, and it's always 1 less than the term number. Okay, so now just a final answer, which I do in black, very color-coded for this section. 1 times y to the fourth is just y to the fourth, plus 4 times 2 is 8, y cubed, plus 2 squared is 4 times 6 is 24, y squared, plus 2 cubed is 8 times 4 is 32, y, plus 2 to the fourth is 16. Again, very organized. I know it's time consuming, but we'll get that process down. It won't be bad. Now, 2x minus 3 cubed, I'm just going to pull this screen up a bit. So sorry, everything else is disappearing. Hope you paused. If you didn't, well, you're currently hearing me, just rewind. 2x minus 3 cubed. So we're doing cubed, which means it's going to go 1, 3, 3, 1. Those are our binomial coefficients. Now in blue, here, 2x is being used for like the quote unquote x. So this is 2x to the third, 2x to the second, 2x to the first, and no 2x. And then in pink, negative 3 is being used for y. So this is negative 3 to the 0, negative 3 to the first, negative 3 to the second, and negative 3 cubed. Then final answer, I just multiply things out. So 2 cubed is 8, so 8x cubed, plus 2 squared is 4, times 3 is 12, times negative 3 is negative 36. So I'm actually going to get rid of this plus, make it negative 36x squared. In this case, I will have a plus. I'll keep it. 2 to the first power is 2, times 3 is 6, times this will get positive 9. 9 times 6 is going to give me 54x. And then negative 3 cubed is just going to give me negative 27. Again, it's sort of a fun process. I mean, I'm having fun. You may not be, but I'm having fun. And generally, it's not that bad. It's just, again, very, very tedious. This too, it's not part of the binomial expansion. It's just going to come down, hang out at the end of our problem, then be applied to the final answer. So really what I'm expanding is x plus 3y to the fourth power. So it's to the fourth power. So we go 1, 4, 6, 4, 1. Then in blue, the thing in place of x is x. That's nice. So we're just going to have x to the fourth. Look, I lost the parentheses because I knew it was just x. X to the third, x squared, x to the fourth, no, x to the 0. And then in pink, I'm going to have parentheses because I have 3y. So 3y to the 0, 3y to the first, 3y to the second, 3y cubed, and 3y to the fourth. Then for our binomial expansion, we now have x to the fourth, plus 4 times 3 is 12, x cubed, plus 3 squared is 9, times 6 is 54. I lost a y here. Nobody stopped me. X squared, y squared. So our x was squared and our y was squared. Plus 3, this is cubed. It doesn't look like it. 3 cubed is 27. Times 4 is 108. X, y cubed. Plus, and then 3 to the fourth power, which is going to give me 81, y to the fourth. Notice again, my x's decrease. X to the fourth, third, second, first, 0. My y's increase. 0, 1, 2, 3, 4. This whole thing has a 2 in front of it. That's now going to get distributed. Easy part here at the end. So 2x to the fourth plus 24 x cubed y plus 108 x squared y squared plus 216 xy cubed plus 162 y to the fourth. All right, not bad at all. So this is the whole like binomial expansion. It is the longest of the problems that we do. So now we move into some easier stuff and some shorter stuff. So find the specified term of each expansion. So here, I have x minus 5 to the 6th power. These are separate problems. And I'm being asked to find the term that has x to the 5th. So what you want to be thinking about in this case, it's to the 6th power, which means you have x to the 5th. Here's x, here's y. And this would also mean that I'd have like a negative 5 to the 1st power. And I know that because the sum of these two terms has to be equal to 6, whatever our power is. So how does that help me? Well, right here, this is my r value. So I know that r is equal to 1. So what I'm allowed to do then is a 6 choose 1. And that gives me the binomial coefficient for something like this. So it's giving me these red numbers. So if I do 6 choose 1 in my calculator, or if I looked at my Pascal's triangle, I'd get 6. But it's asking for the whole term, not just the coefficient. So it's 6, and then this x term is being raised to the 5th. This negative 5 term is being raised to the 1st. So that's going to give me negative 5 times 6, negative 30, x to the 5th. You include the variables in that answer. All right, here, I'm looking for the y to the 7th term. I'll switch the color real quick. If I'm looking for the y to the 7th term, that means I'm also looking for the 4 to the 3rd term, because the sum of these has to be 10. Your r value is whatever the exponent of that second term, the 4 in this case, is. So my r value is 3. So I'm doing 10, choose 3, or written like this. And either way that you write that, you get a binomial coefficient of 120. And then you account for any changes that were happening here. So this is y to the 7th and 4 to the 3rd. Now 4 to the 3rd is going to give me 64 times 120 is going to give me 7,680 y to the 7th. All right, and then last, we're looking for the x cubed y to the 5th term. So notice y is my second term, which means we've given you the r value right away. So I'm going to do an 8, choose 5 to get the binomial coefficient. Sorry for not changing the color. That binomial coefficient is going to give me 56. Then I look at this x term, and it's not just x, it's 2x that's being cubed. And my y term is a negative y that's being raised to the 5th. 2 cubed is going to give me 8. Times 56 is going to give me 448 x cubed. And then the negative to the 5th will give me y to the 5th, but it would be a negative. So that negative does not come from here or here, it comes from the y. So that's finding just a specific term in the binomial expansion without actually multiplying all of it out. Again, you are going to want to see sort of where this n choose r or n pick r, which is something we'll talk about later on, where that comes up in the calculator, which I'll tell you it's under the probability feature. I think you hit stat, and then you go right like 3 or 4 times. All right, evaluate the difference quotient. This is thrown all the way back to the beginning of the year. It was always really fun stuff. The difference quotient, here's our formula. F of x plus h minus f of x over h. So when I have x squared, what I'm doing here is saying you're replacing x with x plus h. So I'm going to have x plus h squared. All I've done is replaced x with x plus h minus the original function, x squared, over h. Now, this is just regular FOIL. We know how to do that. So we get x squared plus 2xh plus h squared. So that's the FOIL, minus x squared over h. What should happen here is your x squared should cancel. And then in the numerator, I can factor h out to get 2x plus h. And now my h's can cancel. So I get 2x plus h. Now, this won't be like a huge theme throughout the topic, but it leads into something that's going to be important for calculus as well. Now, when I have x to the fourth, that's x plus h to the fourth minus x to the fourth over h. Binomial expansion allows me to know what's going on with this x plus h to the fourth. So it's going to be x to the fourth plus 4x to the third h plus 6x squared h squared plus 4xh cubed plus h to the fourth. And that's all just the binomial expansion minus x to the fourth. That comes from right here. All over h. X to the fourths cancel. I can factor an h out of all of this, and it's the only thing I can factor out. So I get 4x cubed plus 6x squared h plus 4xh squared plus h cubed over h, and the h's cancel. So I'm left with just 4x cubed plus 6x squared h plus 4xh squared plus h cubed. All right, and then the last thing that we're going to talk about, just a little bit of extra practice, finding the nth term. Now, this is different than finding something like this, just in terms of what I'm exactly giving you. So here, finding the nth term, again, this is 3 separate problems. And I'm apparently not leaving very much space for that one. That's okay, I'll fit it in there. So I have x minus 3 to the 6th power. Now, if I'm looking for the third term, remember that the term number and the r value are not the same, because you're starting with an r value of 0. Term number 1 is, n equals 1. The first term in all of your Pascal triangles is r equals 0. So n being equal to 3 means that r is actually equal to 2. Just like we talked about in previous ones, I'm jumping back, don't worry. Well, we talked about it somewhere where, yeah, so I remember now. Right here we had the third term, but r was 2. So n is 3 here because it's the third term in our sequence, but r is 2. Okay, yeah, so hopefully we have that down. So r is equal to 2 here. That means that what I'm doing is a 6 choose 2 to get my binomial coefficient. That binomial coefficient is 15. And then I have an x that's being raised in that third term. So I'm going to have r to the second. That means I'm going to have x to the fourth because the sum has to be 6. So I'm going to have x to the fourth. And then negative 3 is not really r, it's y. Negative 3 is being raised to the second power. So we get 15x to the fourth times 9, which is going to give us 135 x to the fourth. All right, we'll move through that one a little bit fast, so I'll go a little bit slower in this next one. We're looking for n being equal to 7, the 7th term. Now, what we know about the 7th term is that the r value is going to be 6 because the first term, r is 1. So what that means that we have going on here is the second thing, that's where we get r from, is being raised to the 6th power. The sum of the exponents has to be equal to 9, so the 2y must be getting raised to the 3rd power. So I know part of this already. 2y to the 3rd, 4 to the 6th. And then in order to get the binomial coefficient, I do 9, choose 6. When I do 9, choose 6, I get 84. And then when I multiply 84 times 2 cubed times 4 to the 6th power, I get 2,752,512 y cubed. All right, and our last problem, we sort of need a color here. We'll go back to blue. We're looking for n being 3, so we're looking for the third term, which means our r value is 2. R comes from the second term in the binomial, regardless of the fact that this is switched. So it's negative x to the second, which means that negative 1 must be being raised to the third power because the sum of these must be 5. So I'm going to be doing 5, choose 2. When I do 5, choose 2, I get 10. And then I have negative 1 cubed, negative x squared. Negative x squared gives me a positive x squared. And negative 1 cubed gives me negative 1. So this will be negative 10 x squared. Again, a couple things that you definitely should be asking about. You should be asking about, how do I do this in the calculator? And you maybe are still going to have to play around with some of these relationships between like r and the second term, or the first term and the n value, the term number. So there's still a lot in this section for you to sort of figure out. And you're going to do that by working on some of that homework. So I would recommend that you get started on that. Maybe some of this, try and play around again in the calculator. I think it's under stat, but I don't have a calculator in front of me. Good luck finding it. And it literally says like NCR. You don't want NPR. We'll talk about that in the next section. All right, thanks for joining.